Physics Blender. I love 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 Physics Blender. Subscribe for more videos.
Hello everyone, welcome to Physics Blender e-learning platform. Today we are discussing momentum. Momentum, it's a topic for extended candidates only. We have paper 2 classwork. We have 15 questions. Before we start, kindly go and check notes playlist. You will find notes about momentum. As usual, we will start by KWL chart. You can find all documents, KWL charts, bubble sheets, questions, mark schemes if you join Physics Blender Telegram channel. You can read here for extended candidates what are the main points you have to learn. Starting by our KWL chart, you will write down here what you know already about momentum, what you want to know about momentum. For example, if momentum is it vector or scalar quantity, what are the equations used to calculate momentum, what are the units used to measure momentum, why it's important to know more about momentum, why is it important in our daily life. At the end, you will write here what you learned and check that all the points here are discussed. Okay, let's start by question number 1. Question number 1, we have a constant force acts on a body causing momentum of this body to increase. Which expression relates force to momentum and time taken? Before reading the choices we have here, let's revise the relation between Newton's second law of motion and momentum. If you remember, Newton's second law of motion states that the resultant force acting on a body is equal to the rate of a change in its momentum. Or you can simply start the equation you know already, that F, the resultant force, is equal to mass times acceleration. And you know acceleration is equal to change in velocity divided by time taken. Okay, so if you rearrange this equation, you can find that the change in momentum is here already. So we have here resultant force is equal to m delta v divided by delta t, which is equal to the force. This m delta v is called change in momentum. So the correct answer for this question is A. Force is equal to change in momentum divided by time taken. I would like to mention some important points related to this equation. First of all, we can write that force, the resultant force, acting on a body is equal to the rate of change in its momentum. So this point is very important. Okay, what else? The relation between force and time taken. The longer the time of collision, the smaller the force. and this point is very important for safety, in car safety. Using airbags, using a seat belt, all these features are used to elongate time of collision, so the force acting on the driver will be less. And we have many questions discussing this in paper 4. Okay, so the answer for this question is A. Question 2. A vehicle of mass 900 kg is traveling with a velocity of 20 meters per second. Calculate its momentum. What you have here, mass is given 900 kg. Check that you have consistent units. Velocity is given, which is 20 meters per second. Simply, you have to apply the equation. Momentum is equal to mass times velocity. Mass is given, velocity is given. The final answer 18,000 kilogram meter per second. So the correct answer is C. It's very simple. Question 3. We have here a moving body undergoes a change of momentum. So guys, take care if you have change in momentum or you have momentum. But here we don't have any calculations, just the unit for change of momentum. The unit for measuring momentum, changing of momentum, the same as momentum. But if you look at the choices we have here, you know that kilogram meter per second, it's the unit used for calculating momentum, for measuring momentum. But here we have Newton meter, Newton per meter, Newton second, Newton per second, which are some units here for measuring impulse. What do you mean by impulse? Impulse means it's like a term used to describe the effect of force acting over certain time interval to change the momentum of an object. Okay, so impulse is equivalent to change in momentum. Change of momentum, which is m delta v. Okay, what is the main equation used to calculate impulse? Force applied times the time interval which is taken to change the momentum of an object. Simply, it's just rearrangement of the equation we wrote in question number 1, applying resultant force, Newton's second law, mass delta V divided by delta T. So this equation is the main one, the main equation, and you can rearrange it to find or to calculate impulse. So impulse is equivalent to change of momentum. What is the unit here? Force is measured in Newton, time is measured in second, which is also equivalent to mass is measured in kilogram, delta V, change in velocity, meter per second. Okay, so these two units are correct units for measuring impulse or change in momentum. Is it clear? So the correct answer for this one will be Newton second. Question 4. An object of mass 50 kg accelerates from a velocity of 2, not 20, 2 meters per second to velocity 10 meters per second in the same direction. What is the impulse provided to cause this acceleration? Okay, simply, again guys, you know the equation for calculating impulse. is equal to change in momentum. Okay, so force times delta T is equal to m delta V. The mass we have here, okay, let's explain delta V here is final velocity minus initial velocity. So final velocity minus initial velocity, this can be simply used to calculate the change in velocity. When you substitute here, mass is given already. Check that you have consistent units. So you have the final velocity is 10 minus 2. So your answer is 50 times 8, which is 400 Newton second. The correct answer is B. Check that you have consistent units. Check that your final answer is realistic. I would like to explain here, if you have force graph representation, force versus time, okay, and you have here a graph like this, for example, okay, the area under the graph will be representing impulse. So here this will be representing impulse. This point is very important. Area under the graph, if you have a force time graph, area under the graph is impulse. Again, area under force time graph is impulse. Check your final answer is realistic. Don't just write down what is produced in your calculator. Question 5 is challenging question and is very important. We have here case of collision. In any problem, any question in paper 2 or paper 4, we have collision. I would like you to apply the principle of conservation of momentum, or what we call it, the conservation law of momentum. Okay? Total momentum before collision of the two objects is equal to total momentum after collision. Okay, so let's write here the principle of conservation of momentum, that we have total momentum before collision is equal to total momentum after collision. Okay, so we have here, we will consider this M1, we will consider this M2. Okay, U1 is the initial velocity for the first object, U2 the initial velocity for the second object. So when we substitute here, so we have M1 U1 plus M2 U2 should be equal to M1 V1, which is the final velocity of the first object, plus M2 V2, the final velocity of the second object. Okay, but in this case the two objects will stick together. What do you mean by stick together? After collision they will act as one object. So we can consider here that they have, so M1 plus M2, and they will have like common velocity. So they will have the same velocity. their final velocity v1 and v2 will be the same. Okay, you can imagine, to make it simple, when the driver is traveling at a very high speed, he is sitting inside the car, but he has the same speed as the car, this high speed, although he is sitting in the car, because now they are as one object. So the driver has the same speed, the same high speed as the moving car. Okay, so when you substitute, so m1, the mass of the first one is 3 times 6 u1 plus m2, which is 2 times, pay attention here, u2 in opposite direction to u1. Since velocity it's a vector quantity, when you are using this equation, pay attention, you are using negative sign, because here velocity in opposite direction to u1. So I will substitute here negative 2. Okay, is equal to m1 plus m2, which is 3 plus 2, and the unknown velocity is v, the velocity of the two objects when they stick together after collision. Applying this equation, substitute, get your final answer. So you have here 18 plus minus 4 is equal to 5v. Okay, so you have here 14 equals 5v. So v is equal to 14 over divided by 5, which is 2.8 meter per second. This 2.8 meter per second is the magnitude of the velocity. How can you find the direction? If you get your answer positive, so the direction is to the right, because we consider this one is the positive one. If you get your answer negative, so we consider it to the left, because we consider this case the negative sign. Okay, so this answer is 2.8. The direction will be to the right, because you have positive numerical value here, the numerical value representing the magnitude of the velocity. Since you have the answer in positive sign, so it's to the right. If you have it negative, so it means to the left. Your correct choice is D. So D is your correct answer. Okay, guys, I would like to explain more about the principle of conservation of momentum. That momentum is conserved if no external force acting on a system. And next questions, we will discuss more about the term system. What do we mean by system? Okay, so here the momentum is conserved. The momentum is constant. The total momentum before collision is equal to the total momentum after collision. An object of mass 1.2 kilogram is moving with a velocity of 2 meters per second when it's acted on by a force of 4 Newton. What happens when this force is acting on the object? The velocity of the object increases to 5 meters per second. Can you tell me, guys, what can forces do to an object? What can forces do to an object? Okay, forces can change, they can change direction, they can change shape, Okay, they can change velocity like what we have in our example here. Velocity increases. Okay, also they can allow the object to be at rest if the object is moving, or to start moving if the object is at rest. Okay, so applying the equation, force is equal to change in momentum. Force is equal to change in momentum divided by time taken. When you apply this equation, you rearrange, so time taken will be equal to m delta v divided by force. Substitute delta v, as we said earlier, we have v final, the final velocity, minus v initial divided by time, divided by force. So when you substitute here, you have, let's rewrite it. Okay, so m v final minus v initial divided by f. When you substitute, you have mass 1.2 times 5 minus 2 divided by 4 Newton. Check that you have consistent units. So your answer will be 1.2 times 3 divided by 4, which is 3.6 divided by 4. Your final answer is 0.90 seconds. Check that your final answer is realistic, okay, and you are using consistent units. Okay, question 7. This question also is challenging question. We have a gas molecule strikes the wall of a container. The molecule rebounds with the same speed. This point is very important, with the same speed. Before hitting the wall, after hitting the wall, what happens to the kinetic energy and what happens to the momentum? Okay, we know that we have two types of collision, elastic and inelastic collision. Okay, according to the kinetic theory of gas, we consider all collisions between the molecules or between the molecule and the wall of the container, they are perfectly elastic. What do you mean by perfectly elastic? It means no change in the kinetic energy. The average kinetic energy of molecules will not be changed. And also it's mentioned here that after collision it rebounds with the same speed, which means the kinetic energy will not be changed. Okay, so the kinetic energy will not be changed. So we have to exclude A and exclude B. You have to choose between C and D. What about momentum? Okay, momentum, here we have change in direction. We have change in direction. Since momentum is a vector quantity, so we consider that the momentum after collision is changed. Momentum after collision is changed. So the answer is C. Since the momentum is a vector quantity, the direction is changed, so the momentum is changed. But the kinetic energy here, no change. According to the kinetic theory of gas, we consider this kind of collision perfectly elastic, so no loss in kinetic energy. The answer is C. This question is very important. We can write here that momentum is a vector. Momentum is a vector quantity, so it depends on direction. It has magnitude and it has direction. Since the direction has been changed, the momentum is changed.
Subscribe for more videos. I love physics splendor. I love physics splendor. I love physics splendor.